In this lesson, we're going to be finding solution sets to absolute value inequalities. Absolute value inequalities will be the same thing as compound inequalities that we talked about in the last lesson. We have and statements and we have or statements. And so we're going to look at an example of each of these, and we're going to start with and statements. So let's say that case one, we're going to look at our and statements. And so our and statements are going to be anytime that we have a less than or equal to, okay? Easy way to remember this is to get really country whenever you say that and say less than. So we can write that less than. Okay, so anytime that we have the absolute value of something is less than something else, it's an and statement. And so let's look at this example. Okay, here we have 4 times the absolute value of 2x minus 3 plus 5 is less than 25. And so let's do the same thing that we would do if we were solving an equation like this, where you want to get the absolute value by itself. So I need to subtract 5 from both sides to get those 5s to cancel out here. So I've got 4 times the absolute value of 2x minus 3 is less than or equal to 20. And now I still have this 4 being multiplied to the absolute value. So I can divide both sides by 4 so that those 4's cancel out. And I'm just left with the absolute value of 2x minus 3 is less than or equal to, to 5. Okay. And so now I have my absolute value by itself. So I know that whatever this number is, it is less than or equal to 5 spaces away from 0. So if we think about our number line again, there's two numbers that are 5 spaces away from 0, positive 5 and negative 5. So we can say that 2x minus 3 can be less than or equal to positive 5. 2x minus 3, however, when we're going to compare it to negative 5, we're essentially multiplying this by negative 1. And if you remember from our last lesson, anytime we multiply or divide by a negative number, we have to flip that inequality. So it's going to be 2x minus 3 is going to be greater than or equal to negative 5. So now let's go ahead and solve these two linear equations now. I'll start by adding 3 so that I can work on getting the x by itself. So I have 2x is going to be less than or equal to 5 plus 3 will give me 8. And 2x is going to be greater than or equal to negative 5 plus 3 will give me negative 2. Now I can divide everything by 2. So I will get x is going to be less than or equal to 8 divided by 2 would give me 4. And x is going to be greater than or equal to negative 2 divided by 2 will give me negative 1. Okay. So now we have these, my two inequalities here. And so we're going to go ahead and graph these on a number line. I'm going to do it out to the side here. And so I've got 0, negative 1, and 4. All of these have the line underneath it, so we're going to do a closed circle at negative 1 and positive 4. And if we're thinking about this, we want all of the x values greater than negative 1 and all the x values less than negative 4. So greater than negative 1 would be this way, and less than 4 would be this way. So we want to highlight all of my values inside of here. And we can write this in interval notation as well. Right, my leftmost point would be negative 1, and we have a closed circle, so that's going to be a bracket, negative 1. And on the right, I have 4 with another bracket, so this would be my answer represented in two different notations. I want to take a second to show you what this looks like on the graph. So if I add in my absolute value piece, the left side of my inequality, I get this V shape, which we talked about in our solving absolute value equations video. But now if I add in y is less than or equal to 25, I get this shaded red area, and it also this line that intersects at 2 points. And if I click, I can see that it intersects at -1 and 4, which were the 2 points that we found. And I can see that everything in between these 2 points on that absolute value graph is shaded in that red area, which means it's a part of my solution set. So I think that's a pretty cool way to visualize what we just did mathematically. Now we're going to look at our second case, which, if you couldn't have guessed, it's going to be our or statements. So let's go ahead and draw a line and say case 2 is going to be our or statements. Okay. Now our or statements is just the opposite of an and so it's going to be dealing with our greater than or equal to symbols. And instead of getting very southern this time, we're going to get very proper and say that these are going to be greater. So anytime that we see a like a greater than or equal to, we can read it very formally and say it's great or, to remind ourselves that this is an or statement. And so now let's go ahead and work an example. We have 10 plus the absolute value of 3x is going to be greater than 70. And so let's go ahead and get the absolute value by itself. And I need to do that by subtracting 10, since that's being added to the absolute value. And when I do that, I get the absolute value of 3x is greater than 70 minus 10 would be 60. And so now my absolute value is isolated, so I can set it into two separate pieces. So I'm going to have 3x is going to be greater than 60. And just like last time, we're going to say 3x and negative 60. But since I have the negative now, I multiply by a -1. I need to flip the inequality the other way. So we have 3x is less than 60, negative 60. Now this one's pretty easy to get x by itself because all I have to do is divide 3, and I'll do that everywhere. So we're going to get x is going to be greater than 20, and x is going to be less than negative 20. Okay. And we can draw that on our number line now. We've got 0, we've got negative 20, and we have positive 20. And so since both of these don't have the line underneath them, I'm going to make the open circle at negative 20 and 20. And now what we're saying is that we want all the values less than negative 20, which would be all of them this way. So I'll highlight all of that. Or we want all the values that are greater than 20. So I'll highlight all of my values this way from 20. Now we can write this in interval notation. We're starting to the left, and we see that it's going to negative infinity. So I'll do parentheses negative infinity all the way up to negative 20. And if you remember to write or in math, we're going to use this big U. And then I'm starting again at positive 20 and going to positive infinity, since there's nothing stopping me going to the right now. And so here is my answer in inequality notation and an interval notation, and I have it on the number line. Let's again just take a quick look at what this looks like on the graph. And so if I add in my absolute value piece, the V shape, I see that I get this V, and then if I add in the y is greater than 70, I get this green shaded area. One thing to note is that this time it's a dotted line. Last time it was a solid line. Anytime you have this dashed line like this, it means that whatever points these are going through, it's not actually in the solution. It just gets really close. But if I click on this, I see I once again get my two solutions where they intersect at negative 20 and 20, which is exactly what we found. And I see that everything is kind of the opposite of what we had last time. Last time we had kind of the inside piece of the V shaded, but this time it's everything going to the left of negative 20 and everything going to the right of positive 20. And so it's just the opposite of what we did. And so I hope you've had as much fun as I have looking at these absolute value inequalities. Good luck in your practice, and I'll see you in the next video.